Yo, what's up everyone? Welcome back. Patrick here. Moving on to the next section in calculus. We're now going to talk about L'Hopital's rule. And this is a pretty popular concept that comes up in a lot of calculus courses. And basically what L'Hopital's rule is, it's basically another tool that's used to solve or to find limits. So we've gone over a bunch of tools already to solve limits, whether that's with factoring, rationalization, change of variable, or maybe even limits at infinity. We went over different methods. So L'Hopital's rule is just basically going to be another tool used to find limits. And more specifically, the limits have to be in something called indeterminate form. So it's a tool used to find limits that are in indeterminate form. And I'm going to describe in a second what indeterminate form is. So basically, just to show you kind of like a flow of what's happening, you're going to get a limit. If it's in indeterminate form, which I'm going to describe in a sec, you could potentially use this tool. So it can't always be used for limits in this format, but more often than not in your specific course, it will be able to be used. So you can potentially use L'Hopital's rule. And in this specific video, what I'm going to do is I'm actually going to introduce the two most popular indeterminate forms. Now there's actually a bunch, and I'm going to introduce more forms later on in the section. But first I'm going to introduce the two most popular ones. And the reason why is because, first off, most questions, most limits that you're going to get are going to be in one of these two formats. And so I'm going to introduce them here, and then I'm going to go over a bunch of examples. And then also the other forms I'm going to introduce, a lot of them can be converted to these two. And then you would just use the same techniques that I'm going to show you in this video. Right? So these two that I'm going to introduce are the most popular, but there are other forms, but I'm going to introduce them later in the section. So the first most popular indeterminate form is if a limit is in this format. If you have 0 over 0, and then the other one is if you have positive, plus or minus infinity actually, over plus or minus infinity. So examples of both of these is, let's say we got the limit as x approaches 2 of x squared minus 4 over x minus 2. And an example of this one is, let's say we got the limit as x approaches infinity of 1 minus, let's say 3x over, I don't know, let's say 2x plus 1. Okay, so notice that with both of these, if we do a direct substitution, we're going to have it in this format. So if we sub in 2 for the x's, notice the numerator is going to be 0, the denominator is going to be 0, and we can't determine this limit with a direct substitution because it's going to be in this form. It's going to be in indeterminate form. We can't determine it. That's where that wording comes from. Right? So if we do a direct substitution here, we're going to have 0 over 0. It's going to be in this format. And then notice if we plug in infinity here, what are we going to get? We're going to have 1 minus 3 times infinity. So we're going to end up with a very large negative number. It's going to go towards negative infinity, that numerator. And then if we plug in infinity, a very large positive number for this x, we're going to have 2 times infinity plus 1, which is going to be positive infinity. And notice from a direct substitution, we can't figure out what that limit is with that right there. Right? It's in indeterminate form. So we got to use other tools. And with these two limits specifically, we actually know how to solve these with tools that we've already gone over. So notice this limit, specifically, we can use factoring. So notice the x squared minus 4, that would be x minus 2, x plus 2, all over x minus 2. And then notice that those factors will cancel out. Sorry, just keep it proper here. I should write limit as x approaches 2. Those factors will cancel out, and now we could do a direct substitution and plug in 2 for x and we would end up with 4. Right? So this limit here is equal to 4. We can use factoring. Notice this here, it's a limit at infinity. And if you remember from the limits at infinity section, what we can do is we can divide all these expressions by x to the power of the highest exponent. Notice the highest exponent is 1. So we could take 1 divided by x minus 3x over x, which would be 3. 2x over x, which is 2, plus 1 over x, like that. And then notice that this 1 over x, as x goes to infinity, a number over infinity is going to go towards 0. A number over infinity is going to go towards 0. So we'd end up with negative 3 over 2. That's what this limit is going to be. So even though these limits were in indeterminate forms, we do have tools where we can solve these limits already from previous sections. However, you're also going to start running into limits that you don't have tools for yet, that are going to be in these forms that you can't solve. So, for example, let's say that I give you a limit as x approaches 0 of, let's say, 5 to the x minus 2 to the x over x. Notice if we do a direct substitution here, we'll have 5 to the power 0, which is 1, minus 2 to the power 0, which is 1. 1 minus 1 is 0. And then we'll have 0 in the denominator. So notice that this here is in that form. And notice that we can't really factor this, can't really rationalize it. We don't really have a tool yet to be able to solve this limit. An example of a limit in this format would be, let's say we got the limit as x approaches infinity of, let's say we got ln x over ln of x squared. Notice if we do a direct substitution, ln of infinity is infinity, and then ln of infinity squared is going to be infinity as well. So if we do a direct substitution, it's going to be infinity over infinity. So we can't do a direct substitution. There's going to have to be some other tool that we use to solve this. So the question is, how do we do that?